Hello students, welcome to OMSAS Academy. Today we are going to learn class 10th Maths Chapter 1 Real Numbers Part 7 Rational and Irrational Numbers and Theorem 1.3 and Theorem 1.4. Hello students, welcome to OMSAS Academy. Today we are going to learn a new topic, that is rational numbers and irrational numbers. This is just a revision of what we have learned in class 9, right friends? Just let us recall what are the rational numbers. Rational numbers are those numbers which has three given conditions. First is they are always in which form? P by Q form, right friends? Where P and Q, that is the numerator and denominator, are integers. That can be negative, positive, 0. Okay, but Q should not be equal to 0. That is, the denominator over here should not be 0. If all these three conditions satisfies, then we say that the number is a rational number. Right friends? Say for example, minus 3 upon 5 is a rational number. Yes. Why? It is written in P by Q form. Yes. Then second is P and Q दोनों integers है. P is a negative integer and Q is a positive integer. Yes, so they both are integers. And Q, that is denominator, that is 5, which is not equal to 0. So all these three conditions satisfy. So then this number is called as a rational number. But suppose if we write 0 upon 5, is it a rational number? Yes friends, it is a rational number. Why? Because 0 upon 5 is written in P by Q form. First condition satisfies. Second condition is P and Q should be integers. So 0 is also integer and Q is 5. 5 is also integer. And third condition, that is Q should not be equal to 0. So यहाँ पे Q आपका 5 है. It is not equal to 0. So 0 upon 5 is what? 0, and which is a rational number. Is it clear friends? So this is also a rational number. But suppose if I am given reverse, that 8 upon 0, is it a rational number? So the answer to this is not defined. Okay, answer to this question 8 divided by 0 is not defined. So in this case, your first two conditions satisfies. That is, it is in P by Q form and P and Q both are integers. This both condition gets satisfied. But the last condition, that is Q should not be equal to 0, this condition does not satisfy over here. Is it clear? यहाँ पे Q आपका 0 है, इसके लिए this number, so this number is called as what? Irrational number. Is it clear? This cannot be called as rational numbers. Now let us come to the irrational numbers topic. Irrational numbers are those numbers which are not rational. The simple definition of irrational numbers are those numbers which are not rational are called as irrational numbers. Simple and easy. Is it clear? So those numbers which are not rational are called as irrational numbers. Is it clear friends? Now what type of irrational numbers are there? There are some conditions in irrational numbers, that if P is a prime number, comma, then root P is an irrational number. This is very easy concepts. So what are prime numbers? We know very well. कौन से प्राइम नंबर्स है? The prime number starts from 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47. These are all primes. Okay. So if I put root over here, that is root 2, root 3, root 5, root 7. Okay, this all will be an irrational numbers. Is it clear? So this condition is that if P is a prime and root p will be an irrational number. This is the condition. Now second is, if a is a rational number, suppose if a is a rational number and you are given that root b is a non-zero irrational number. Root b is a non-zero irrational number, and then whatever will be addition between these two numbers, that is a plus root b, will be irrational numbers. Then a minus root b will also be irrational number. A into root b will also be irrational number, and a upon root b, that is a divided by root b, or we can write it as a divided by root b, that also will be an irrational number. Okay, these all are irrational numbers. Why? Because if this is a condition that if any one a is a rational number and root b is a non-zero irrational number, मतलब b जो है वो non-zero irrational number है, zero नहीं होना चाहिए. Is it clear? Then we say that addition of these two numbers, say for example 2 plus root 3. Okay, so here 2 is a rational number. Why? Because we can write it in p by q form as 2 upon 1. But root 3, here it is a prime number and the root of that prime number is an irrational number. So rational plus irrational will get as irrational only. So this whole number will be called as irrational number. Similarly, we can write as 5 minus root 10. Okay, here also, here in this condition b should be what? A is a rational number and root b is a non-zero irrational number. Okay, so if I take out the root of this, it will be non-zero irrational number. So this whole will be termed as an irrational number. Is it clear, friends? Then next is a into root b, that is say 3 into root 2, that is 3 root 2. So this is also an irrational number. Or 5 root 10, this is also an irrational number. Okay, then next is a upon root b, say 3 upon root 7. 3 upon root 7 is also termed as an irrational number. Is it clear, friends? So this is the concept of irrational number. Now next concept we are going to learn theorem number 1.3. So friends, theorem 1.3 says that let p be the prime number if p divides a square, then p divides a, where a is a positive integer. Right, friends? Now see, here what is given, that suppose say p is a prime number. Okay, and say suppose just for your example, if say a is your 12. Okay, and say p is a prime number, say 3, which divides 12. Okay, so sorry, a square, p divides a square, that is what is a square? A square will be 12 into 12. Okay, and p divides this a square. So if I divide this by 3, it gets 3 ones are 3 fours are. Okay, so it gets divided. So p divides a square, then p will also divide a. What was my a? A was 12. So if I divide 12 by p, that is 3, this will also get divided. Okay, where a is a positive integer. So this concept we have to prove it, that suppose any p is a prime number and p divides a square, then p also divides a, where a is a positive integer. यदि p प्राइम नंबर है और p a स्क्वायर को डिवाइड करता है तो p a को भी डिवाइड करेगा. Is it clear? And where a will be a positive integer. So let us prove this, friends. So let the prime factorization of A, let the prime factorization of A be as follows. Be as follows. Okay. Here in the previous example, what we took A as a 12. Okay. So what were the prime factors of this? 2 into 3 into 2. 2 3s are 6, 2s are 12. Okay. So in this way, what will be the prime factorization? The prime factorization of A will be as follows. So let us say prime factorization of A is P1, comma P2, comma P3, comma P4, comma dot dot dot, comma till Pn. Okay. So प्राइम फैक्टर्स ऑफ ए कौन से होंगे? P1, P2, P3, P4 टिल Pn. जैसे फॉर एग्जांपल यहाँ पे 2, 3, 2 ऐसे कोई प्राइम फैक्टर्स थे. इज इट क्लियर? सो दे आर नॉट नेसेसरीली दैट डिस्टिंक्ट, नॉट नेसेसरीली डिस्टिंक्ट. इसका मतलब क्या है फ्रेंड्स कि ये सब जो भी प्राइम फैक्टर्स होंगे ए के, they are not necessarily that they should be distinct. जैसे फॉर एग्जांपल यहाँ पे 12 है तो 12 के प्राइम फैक्टर्स किए तो 2 repeated 2 times. So all these 3 prime factors were not distinct. These 2 were similar. Okay. So the prime factors are not necessarily distinct. So now if we make a square will be what? This whole multiplied by this again, that is P1 into P2 into P1, P2, P3, P4 dot 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 Pn into again I'll have to multiply these all prime factors, that is P1, P2, P3, P4 dot 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 till Pn. So if I have to make an a square, I have to multiply this 2 times. This whole a was what? This one. Okay. So a square will be what? This into this again. So therefore we can say that we can also write a square as P1 is repeated 2 times multiplied 2 times, so P1 square comma P2 square comma P3 square comma P4 square comma dot 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 till it will be Pn square. Okay friends, so what will be the answer of a square? That is P1 square P2 square till Pn square. Now we are given that P divides a square. Okay. Now we are given that P divides a square. Okay. A square इसका पूरा ये टर्म था. तो P जो है, P is one of the prime factor and prime number and it divides this a square. Is it clear? So therefore fundamental theorem of arithmetic will say what? That P will be the prime factor among these all terms. Okay. So therefore the fundamental theorem of arithmetic P will be the prime factor of a square. मतलब ये जो a square है, this whole 2 terms are there, उसके अंदर P जो है वो एक prime factor रहेगा. So therefore from the fundamental theorem of arithmetic it follows that P will be the prime factor of a square. Is it clear? So however the uniqueness of fundamental part of theorem of arithmetic says that the only prime factors of a square are only this one. So however the uniqueness of fundamental theorem of arithmetic says that the only prime factors of a square are of A square are P1, P2, P3, P4 dot dot dot. P1, P2, P3, P4 dot 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 till Pn. Is it clear? So here friends, फंडामेंटल थ्योरम की यूनिकनेस ये बताती है कि ए स्क्वायर के प्राइम फैक्टर्स यही रहेंगे. ठीक है, सी what was A has got the prime factors as P1, P2, P3, P4 till Pn. So A square will have these prime factors repeated twice or multiplied twice. So the prime factor of A square will remain as which was the prime factors of A only. Is it clear, friends? So with this we can say that P is one of the prime factor. Therefore P is one of the prime factor of P1, P2, P3, P4 till Pn. ओके, सो इसमें से ये जो प्राइम फैक्टर्स है उसमें से एक प्राइम फैक्टर P भी रहेगा इन दिस केस. सो नाउ सिंस A इज इक्वल टू P1, P2 till Pn, so now A equals to P1, P2, P3, P4 till Pn. Is it clear? So P divides A. Therefore P divides A. Hence proof. Okay. So in this theorem, what we let us revise this theorem once again. First of all, let the prime factorization of A are as follows. ठीक है, फॉर एग्जाम्पल मान लेते हैं कि A जो है वो 12 नंबर है. ठीक है, तो उसके प्राइम फैक्टराइजेशन है 2, 3, 2. So 2 is say my P1, 3 is P2 and 2 is P3 and so on. Okay, so now if I make A square will be what? This will be repeated twice, so A square will be what? 12 into 12. So it will be what? 2 into 3 into 2 into 2 into 3 into 2. Okay, so this will repeat twice. So what was my 2, 3, 2? P1, P2, P3. Okay, into this again P1, P2, P3. Okay, तो यहाँ पे ये क्या कहना चाहते हैं कि A स्क्वायर में यही जो प्राइम नंबर्स थे A के वो ट्वाइस मल्टीप्लाइड होंगे, दैट इज P1, P2, P3, P4 till Pn into P1, P2, P3, P4 till Pn. Is it clear, friends? Now A square will be, if they will be multiplied twice, तो ये क्या हो जाएगा? 2 into 2 क्या हो जाएगा? 2 square, that is वो P1 square हो जाएगा. फिर 3 into 3 क्या हो जाएगा? 3 square, that will be P2 square. Then again 2 into 2, that will be P3 square. So you will get A square in the form of this. Is it clear, friends? This is just for your explanation. Okay, this is not the part of theorem, but I am explaining you by giving the practical example. Now A square का ये आएगा, that is P1 square, P2 square, P3 square, P4 square till Pn square. Now we are given that P divides A square. ठीक है, from fundamental theorem of arithmetic it follows that P will be the prime factor of A square. Is it clear? So A square के ये सब prime factors, ये जो A square का ये जो terms थे उसमें से P will be one of the prime factor, then only we can divide it. So the fundamental theorem of arithmetic says that P will be the prime factor of A square. Now however, the uniqueness of fundamental theorem of arithmetic says that the only prime factors of A square are these only. ठीक है, यूनिकनेस ऑफ फंडामेंटल थ्योरम ऑफ अरिथमेटिक क्या कहते हैं कि जो प्राइम फैक्टर्स सिर्फ A स्क्वायर के हैं वो कौन से प्राइम फैक्टर्स है? जो A के प्राइम फैक्टर्स थे. A के कौन से प्राइम फैक्टर्स थे? P1, P2, P3, P4 till Pn. So only prime factors of A square will be the prime factors of A, that were P1, P2, P3, P4 till Pn. Now P1 is one of the prime factor of P1, P2, P3, P4, Pn. Is it clear? So इन्हीं में से P जो है वो एक प्राइम फैक्टर होगा. जो प्राइम फैक्टर्स A स्क्वायर के थे वो A के जो प्राइम फैक्टर्स थे वही A स्क्वायर के प्राइम फैक्टर्स होंगे. Is it clear? So P will be the prime factor of this P1, P2, P3, P4 till Pn. उनमें से ही एक प्राइम फैक्टर होगा. So now A will be what? A will be this whole, that is P1, P2, P3, P4 till Pn. उसमें से P एक होगा, so we can say that P divides A. Is it clear? इनमें से कोई एक टर्म P होगा, so we can say that P also divides A. Is it clear, friends? So it is very simple that यदि let P be the prime factor and if P divides A square then P will also divide A. यदि P जो है A के स्क्वायर को डिवाइड करता है तो P A को भी डिवाइड करेगा. This is theorem 1.3. Remember friends, we will be using this 1.3 again and again. Okay, so hope this is understood. Now let us move to the next. Next is theorem number 1.4. Okay, so this is also the theorem with proof. The previous one theorem is not asked as to prove you. It is not as in the examinations as a prove that. But in this theorem, this may be asked in your examination that show that root 2 is an irrational. Okay, friends. So let us start that how we can prove this root 2 is an irrational number. So this is very clear case of what we are going to take is hypothesis. Okay, for example friends, if we have to prove that the man is a man, so what hypothesis we take? That let us assume that man is a donkey. Okay, and afterwards we compare the similarities between man and donkey, then at last we get an conclusion that man has these characteristics and donkey has these characteristics. So finally our assumption is wrong and it contradicts our fact. So we say that man is a man. So this is how we are going to prove this root 2 is an irrational, by taking an hypothesis. Okay, so what we will take first as, let us assume, first we will assume that if we want to prove that root 2 is an irrational, we will assume the opposite one, that is let root 2 is an rational number. So let us assume to the contrary that root 2 is a rational number. ठीक है, तो शुरुआत हमने क्या कहां से की, प्रूफ की कि मान लेते हैं कि उसका जो ऑपोजिट है रूट 2 जो है वो रैशनल नंबर है, ऐसा करके हम मानते हैं. इज इट क्लियर फ्रेंड्स? नाउ इन दिस केस so we can find the integers, therefore we can find the integers as R and S such that root 2 is equal to R upon S. Is it clear? तो मान लेते हैं कि root 2 rational number है. Now let us revise what were the characteristics of rational number. They should be in P by Q form and P and Q should be integers. So instead of PQ, what I am taking that root 2 is rational. Suppose if the root 2 is rational, then it should be in P by Q form. So say instead of P by Q form, there are two integers R and S, where S should be not equal to 0. Okay, then only it will be rational number. What was the definition? P and Q should be integer and Q should not be equal to 0. So here in denominator, instead of Q, it is S. So S should not be equal to 0. Is it clear? Now suppose R and S. Now suppose R and S have common factor other than 1. Have common factor other than 1. Okay, so then we can divide by the common factor, then we can divide by the common factor to get root 2 is equal to A upon B, where A and B are co-primes. Is it clear friends? Now what does this say? That मान लेते कि रूट 2 जो है वो R और S, R upon S है, and R upon S have some other common factor. Say for example, root 2 is R upon S. Okay, so R upon S is, say it is something like A into M and B into M. R is something like A into M and S is something like B into M. So what is common factor? M was common factor. So if we divide by the common factor, then we get what? What will be the remaining common factor will be get divided. Then what will remain? A upon B will remain. So where A and B will be co-primes, it means that further division will not be possible over here. Okay, A and B जो है वो co-prime number होंगे. That means उसमें 1 के अलावा कुछ भी common नहीं होगा. They would not have anything common other than 1. Is it clear? So in this case we can write as, so if we multiply this B over here, so we can write as root 2B is equal to A. Okay, so squaring both the sides, if we square both these sides, what we will get? Squaring both the sides and rearranging, comma, we get what? Root 2, the root 2b the whole square is equal to a square. ठीक है, दोनों साइड को मैं स्क्वायर कर रहा हूँ और फिर रीअरेंज करूंगा, तो रूट 2 का स्क्वायर क्या हो जाएगा? 2 एंड b का स्क्वायर क्या हो जाएगा? b स्क्वायर. सो इट विल बी व्हाट? 2b स्क्वायर इज इक्वल टू a स्क्वायर. Okay, so if this 2 comes this side, then it will be what? B square equals to a square upon 2. That is a square divided by 2. Is it clear? So we can say therefore 2 divides a square. 2 divides a square. Is it clear friends? Now by theorem 1.3 it follows that 2 also divides a. यहाँ पे 2 a square को divide कर रहा है. So further I can write as, now by theorem 1.3 it follows that यहाँ पे 2 divides a square, so 2 divides a, it follows that 2 divides a also. ठीक है, मतलब यहाँ पे 2 a स्क्वायर को डिवाइड करता है. तो अभी हमने थियरम 1.3 पढ़ा कि if p is a prime number and if it divides a square then p also divides a. Okay, so this theorem 1.3 by this theorem 1.3, if 2 divides a square then 2 will divide a also. Is it clear friends? So let us substitute a. So we get, let us substitute a equals to 2c. Is it clear? So मान लेते हैं कि a की जगह हम क्या लेते हैं? 2c for some integer c. For some integer c. Is it clear? So a equals to 2c हो गया, हमने कुछ सब्स्टिट्यूट लिया. Now in this case what it will be, that what was my, this was my first equation, say 2b square is equal to a square. Okay, this was my first equation. If I substitute this value in equation first, okay, so what I will get is, two b square equals to a square. Instead of that 2a I will put 2c. So So it will be what? 2b square equals to 2c the whole square. So it will be 2b square equals to 4c square. Okay. Now these two will get divided over there. So it will be what? B square equals to 4c square. Sorry, this 4 I am dividing over here. So 2b square upon 4 equals to c square. So 2 ones are 2 2s are. So therefore it will be b square divided by 2 equals to c square. Okay. So again what came? That here 2 divides a square. Here 2 divides b square. Is it clear? So 2 divides b square. Therefore by theorem 1.3 it follows. So by theorem 1.3 it follows 2 divides b also. Okay. So in this case 2 divides b also. तो 2 यहाँ पे a को भी डिवाइड कर रहा है एंड 2 यहाँ पे b को भी डिवाइड कर रहा है. तो दैट मीन्स व्हाट? 2 इज अ कॉमन फैक्टर. ठीक है. सो therefore a and b have at least 2 as a common factor. ठीक है. तो a और b दोनों 2 से डिवाइड हो सकते हैं, तो उनमें 2 दोनों में कॉमन फैक्टर है. इज इट क्लियर फ्रेंड्स? बट इट कॉन्ट्राडिक्ट्स आवर फैक्ट दैट a and b आर कोब्रेंट्स. यहाँ पे हमने क्या लिया था? व्हाट assumption we took? That a and b were कोब्रेंट्स. Okay, so we can say that it contradicts our fact that a and b are कोब्रेंट्स. Therefore it contradicts our fact that a and b are co-brands. ठीक है. ये हकीकत से ये ऑपोजिट हो रहे हैं. So the contradiction has arisen, therefore because our assumption is wrong. Okay, so therefore we can write our assumption is wrong. हमने जो भी एज्यूम किया था वो गलत है. तो हमने क्या एज्यूम किया था? दैट रूट 2 इज अ रैशनल. हमने ये एज्यूम किया था. सो इट इज रॉन्ग. सो इट इज एन इररेशनल. सो देयरफॉर रूट 2 इज एन इररेशनल नंबर. इज इट क्लियर फ्रेंड्स? सो लेट अस रिपीट दिस वंस अगेन. सबसे पहले हमने क्या किया? फर्स्ट स्टेप टू प्रूव रूट 2 इज एन इररेशनल नंबर. What we did is, let us assume to the contrary that root 2 is a rational. मान लिया कि चलो root 2 है वो क्या है? Rational number है. Is it clear? Then यदि वो rational number है तो it should be in p by q form or r by s form. तो we find that the integers as r and s such that root 2 is r upon s, where s is not equal to 0. Okay, denominator should not be equal to 0 in case of rational number. So we write that s is not equal to 0. Now suppose r and s have common factor other than 1. मान लेते हैं कि ये जो p by q फॉर्म या r by s फॉर्म था उसमें कोई कॉमन फैक्टर है other than 1. Is it clear? So if we divide by the common factor to get root 2 equals to a upon b. r upon s में मान लेते कोई common factor mm था. तो if we divide this and we simplify it, then we get root 2 equals to what? a upon b. Where अभी इसको further division possible नहीं होगा. That means it will be the simplest form. So a and b are co-brands. a and b जो है वो क्या होंगे? हमारे co-brands. Co-brands मतलब they would have nothing common other than 1. So therefore root 2b, this b I multiply over here, so it will be what? Root 2b equals to a. Is it clear? Now squaring both the sides and rearranging. अभी दोनों साइड्स को स्क्वायर करता हूं तो root 2b the whole square is equal to a the whole square. So what will be root 2 square? It will be 2 and b square will be b square is equal to a square. So this is say my equation first. Now what I am taking, this 2 is multiplied, I take that 2 to the next side, so it will get divided. So b square equals to a square upon 2. ठीक है. तो ये क्या है, बी स्क्वायर इक्वल टू ए स्क्वायर अपॉन 2, मतलब यहाँ पे ए स्क्वायर को 2 डिवाइड कर रहा है, सो 2 डिवाइड्स ए स्क्वायर. इज इट क्लियर? सो 2 डिवाइड्स ए स्क्वायर. Now what we have learned in theorem 1.3 that it follows that 2 also divides a. Okay, if 2 divides a square, then as per theorem 1.3 we can also say that 2 divides a, that is square root of a square. Okay, so let us substitute a equals to 2c. ठीक है, फिर हमने क्या किया कि substitute किया a equals to 2c for some integer c in the equation 1. Okay, so in equation 1 I am writing here, let us substitute a equals to 2c in equation 1. तो फर्स्ट इक्वेशन हमारा क्या था, ये वाला इक्वेशन था, दिस वाज आवर फर्स्ट इक्वेशन. इसमें हमने सब्स्टिट्यूट किया a equals to 2c. So instead of a I put 2c over here, so it will be 2c the whole square. So what will be further, 2b square equals to 2 का स्क्वायर क्या हो जाएगा 4 and c square will be c square, so 2b square equals to 4c square. Okay, now these 4 I am taking to the next side, so it will be c square equals to 2b square upon 4. Okay, then it will be what, 2 1s are 2 2s are, so it will be b square upon 2 is equal to c square. Okay, so here 2 divides b square, यहाँ पे b स्क्वायर को 2 डिवाइड कर रहा है. ठीक है, जैसे यहाँ पे a स्क्वायर को 2 डिवाइड कर रहा था तो 2a को भी डिवाइड कर रहा था. नाउ यहाँ पे b स्क्वायर को 2 डिवाइड कर रहा है तो 2 डिवाइड्स b स्क्वायर, सो बाय थ्योरम 1.3 इट फॉलोज दैट 2 विल आल्सो डिवाइड b. इज इट क्लियर? सो therefore a and b have at least 2 as a common factor. तो दोनों में 2 से डिवाइड हो रहा है, a भी 2 से डिवाइड हो रहा है, b भी 2 से डिवाइड हो रहा है, तो उसका मतलब a और b में 2 जो है एज अ कॉमन फैक्टर है, दोनों में 2 इज देयर एज अ कॉमन फैक्टर. सो देयरफॉर इट कॉन्ट्राडिक्ट्स अवर फैक्ट. सो हमने क्या लिया था कि a एंड b जो है वो को-प्राइम है, मतलब उसमें r और s जो थे दे वर नॉट को-प्राइम्स, बट when we simplified r and s we got a and b, they were the co-primes. Okay, that means further division was not possible. पर यहाँ पे तो a और b जो है उनमें दोनों में 2 कॉमन फैक्टर आ रहा है, मतलब a and b में फर्दर डिवीजन भी पॉसिबल है. तो these contradicts our fact that a and b are co-primes. तो a and b में यदि फर्दर डिवीजन पॉसिबल है तो उसका मतलब a and b जो है वो co-prime नहीं है, तो that contradicts our fact. So therefore our assumption is wrong. तो हमने जो assume किया था वो पूरा हमारा assumption जो है वो गलत है, it is wrong. Okay, so therefore what was our assumption, that root 2 is a rational. So this was our assumption, but here our assumption is wrong, that means root 2 is an irrational number. Is it clear, friends? Hope it is understood. So friends, with this we end today's topic. Thank you.
Thank you students for watching this video. To view our more videos, please click on like and subscribe button given below. Thank you.